Lesson 9.3, section 9.3, when they give you the center and the vertex of an ellipse, and they give you an additional point, how can you find its equation and how can you graph it? Now, there are some information here that you have to know before you start solving this problem. For an ellipse, the vertices, center, and foci, they all lie on the y-axis. The x-coordinates of the center and given vertex are the same, so the major axis is parallel to the y-axis. Therefore, assume the equation of the ellipse whose center is at h, k, has the form shown below where a and b, and they are all greater than 0. We're going to look at the equation for the ellipses. So the ellipse where the major axis is parallel to the y-axis, the equation we need is x minus h squared over b squared plus y minus k squared over a squared is equal to 1. Now here, h and k, they represent the vertex. The center is, the center is 2, negative 1. So h and k, they represents the center. So h is 2, k is negative 1. The distance from the center of an ellipse to a vertex is a. To find for this ellipse, find the distance from the center, 2, negative 1 to the vertex, 2, 7. So if you look at the distance between 2, negative 1 and 2, 7, x values are the same, but there is a vertical difference. The difference between negative 1 and 7 is 8. Notice that center 2, negative 1 and the point 10, negative 1 are on a line perpendicular to the major axis. So they are on the minor axis. This means that the distance between these points is b. So now if you calculate the distance between the center and the additional point given, the y values are matching. So there's a difference between the x values. So the distance between them is 8, which makes your b value. So a value is the distance between the center and the vertex. So that's a. And then the b value is the distance from the center and to the given point, and that's also b. If a and b is equal to each other, this equation violates the inequality that was assumed earlier, which is a is greater than b and b is greater than 0. This contradiction means that this ellipse is actually a circle with a center at 2, negative 1, and its radius is 8. The equation for the ellipse whose center is 2, negative 1, that has a squared is equal to 64, b is equal to 64. So if you look at the equation we provided at the beginning here, so a squared is h squared, b squared is equals to also 64, and h being 2 and y being negative 1. If you plug them in, this is the equation you are at. This equation is equivalent to the standard form of a circle with center 2, negative 1 and the radius is 8. To graph the circle, you can use the center 2, negative 1 and given points on the circle. Again, for the graphs, you can use always the Desmos calculator, and then you can also find the equation. So this means that all circles are ellipses, but not all ellipses are circles. This is how you're going to handle this question, finding the a and b value, and then if a is equal to a b, your ellipse just becomes a circle.